Hello students. Today we are in lecture number 48. Lecture 48 of chapter 4, moving charge and magnetism. Dear students, today in this lecture we will study about helix, that is the helical path of a charged particle when it enters into the magnetic field, and the very important application, it is cyclotron. All right, I am B S Pandey. Student, here we go with the first topic. This is helix. Basically, this helix is a particular path, all right, that is the helical path. Of charged particle. We have studied when we fire a charged particle inside magnetic field, it moves on a circular path. No, if you fire a charged particle, it moves on circular path. But if we project a charged particle, suppose the magnetic field is going in this direction, and you project a charged particle. Let me draw. This is your magnetic field. I am representing by red here. Suppose this is the magnetic field in upward direction. All right, and if you project a charged particle in this direction, what will happen? This charged particle will not experience any force due to magnetic field. Am I right? Yes, because we have projected parallel to the magnetic field, velocity parallel to the magnetic field, theta 0, the force will be 0. But if you project a charged particle in this way, perpendicular to the magnetic field, it will experience maximum force. It's quite obvious, projecting this charged particle from 0 degree to 90 degree, the force varies. All right. And the second thing, if you project a charged particle in this way, the charged particle will move in this circular path. All right, in this circular path. But what will happen if you will not project a charged particle exactly in this direction, but by making some angle with the magnetic field in this direction? If you will project a charged particle in this direction by making some angle, what will happen? In this case, you can see here, this is very important to discuss. If you project a charged particle by making an angle with this magnetic field, I am projecting a charged particle in this direction. All right, this is my velocity v. Here it is making an angle theta. I hope it is very clear in my video lecture. If this is v, then this v will have two components here. One, v cos theta, and another, it is v sin theta. All right, which is the parallel and perpendicular. This is v sin theta and this is v cos theta. All right. Now you can see the v cos theta, it is the velocity which is parallel to the magnetic field, and this velocity will carry the charge along the magnetic field without experiencing any force due to magnetic field. Why? Because v cos theta, it is parallel. V cos theta, it is the velocity parallel to the magnetic field, and due to this velocity, the charge will move with constant velocity. Due to this velocity, charge will move with constant velocity, that is the zero acceleration. Am I right? Yes, because no force is acting due to this velocity. Now, due to V sine theta, it is V sine theta, which is perpendicular to the magnetic field. Due to this V sine theta, the charged particle try to move on circular track. But while moving on circular track, this V cos theta will try to take this charge up. That's why this charge moves on a circular track, but it goes up and it makes a spiral that is called the helix. All right, and that we have to study here. We have to cover the two topic in this helix. One is the time period to complete one rotation, and the second, how much distance it cover while moving, while completing one rotation, and that is called the pitch that we have to study. All right, here the Q is the charge. In examination, if this is coming, you have to write Q is the charge. All right, V is the velocity or the speed, you can write. B is the magnetic field. Theta, at which this charged particle projected by making an angle with the magnetic field, and we know that this charged particle will move in a spiral, that is the helical shape, like this one. Okay, yes, it will go in this way, you can see. Now, my dear students, while completing one rotation, it cover this much distance, and this much distance is called pitch. This is pitch that we have to find. But before that, we will try to write the time period to complete one rotation. Hereby, student, we know that time is distance by speed, so let the radius make by this charged particle, it is r. All right, so we can write here the total distance travel, it is 2 pi r by speed, and the speed it is v. But with which speed it is moving on circular track, it is v sine theta. V sine theta. Remember, students, you can put the value of r, we have studied already, it is mv by qb. All right, yes, we have studied in motion of charge, so you can put the value of this r also. I'm not making this one lengthy, directly I'm writing. So this is the time. Now we have to find the pitch, this distance. So how much time it take to cover this distance? It is t, and with which speed it is moving? V cos theta. So this is the distance, and then distance, that is the pitch, we can write velocity into time. So the velocity, it is the v cos theta, and it is the time being this charge travel this much distance. So we are having here the v cos theta times 2 pi r divided by v sine theta. This is the pitch. We can simplify this one also. Okay, so this is the concept of helix, how the charged particle move. You have to remember actually this particular thing, how the charged particle cover and make this path helical. Okay, in this topic you have to study this much. Now, student, the next topic, let me move for the next one. Let me wrap this. Suppose if we will project a charged particle with some potential. All right, now the next topic we are having. With some potential, if we fire a charged particle into the magnetic field, then what will be the radius? Actually, this was asked in CBSC to find the radius in terms of potential. That we are going to do here. That is the charged particle fired with potential V. Charged particle fired with potential difference of V. Alright, this is our potential difference. Remember the topic? What we are going to do here? Suppose you are having a space of magnetic field. Look at here. This is very simple topic. This is magnetic field perpendicular outward. All right, yes. And if you project a charged particle in this way, all right. But remember, from where this charged particle achieve the velocity, suppose it enter with the velocity u. But from where it achieved the velocity? Actually, the charged particle used to accelerate by some potential. Okay, the motion acquired by the charged particle, it is due to the potential energy, and potential energy given by the voltage. As we know that the energy, the potential energy having any charged particle, it is the Q times V, and that charged particle convert that potential energy convert into kinetic energy, and that kinetic energy gives the velocity. All right, yes, this is a charge Q. All right, it is moving inside the magnetic field. After moving the magnetic field inside the magnetic field, it will move on a circular track, and we have to find the radius. Actually, this is our question. We have to derive an expression for the radius. All right, so let me go for this. Remember, V is the potential difference. Potential difference. U is the velocity, the speed, you can say, with which this is moving. M you can take as the mass of charged particle. Q is the charge. All right, these are the quantity. The quantity you will get, you must have to mention in your copy. All right, now if we project a charged particle accelerating by potential V, then potential energy will be equals to the kinetic energy. Am I right? Yes. And potential energy to Q times V, that is half mv square. All right. Here you can find out the velocity. So the U can be written as 2 qv divided by m root under. All right. Yes. 2 qv by m root under. This is the velocity. Now we know that to make the radius, as this charged particle moves inside the magnetic field, at this point the two forces are acting. Inside magnetic field, inside the field, my dear students, we can write here the QVB, here the theta is 90 degree. QVB is equals to mv square. So QVB, this is the velocity actually. So we'll write u mv square, here the u square, divided by r, and this r we have to find. All right, so we can write here the u will be cancel out, and then r can be written as let me write over here. Thus R can be written as mu over qb. Now put the value of m by qb, and u from equation 1 we can put it is 2q v the potential, remember, by m. After solving, overall you will get 2m v over q, I think it is, yes, q b square. So this is the radius. This was the question. You have to derive this r. It is root under 2mv by qb square. The m is the mass, v the potential, q is the charge, and b is the magnetic field strength. Alright students, so in this way you have to proceed. Now let we move for the next topic, which is the very important, and that is called cyclotron. Let me wrap this. Student, kindly note down. Yes. Cyclotron. This is the very important topic. Cyclotron asked in alternate year in your CBSE exams, or the different word also. First, try to understand what is cyclotron. My dear students, cyclotron, it is a device which is used to, you can write, which is used to accelerate heavy positive charge particle up to high energy. Remember, we need some mass that cyclotron will provide the momentum. So it is used to accelerate heavy charge particle like proton alpha particle. Okay, heavy charge particle, positive charge particle, there should be particle up to high energy. After moving on circular track, the energy goes up. We know that if radius will increase, radius of circulating charge particle will increase, the velocity increase, and due to increase in velocity, the kinetic energy will also increase. And this is the particular working method of cyclotron. Okay. Anyway, we have studied the cyclotron is the device which is used to accelerate heavy charge, positive charge particle. Alright, this is the definition, or you can say the introduction of the cyclotron. In examination, you will be asked to write the principle of cyclotron. So this is the principle. This principle I will explain after making the diagram, but right now you have to only remember, you have to only write the principle. It is based on resonance condition. Principle, it is the resonance condition of frequency. What does it mean? Resonance condition of frequency. It means the frequency of charge, circulating charge, should be equal to the frequency of oscillator. What is this oscillator? What is this charge frequency? We are not getting anything, sure. Alright. When I will make the diagram, you will get it easily. So, the frequency of charge particle should be equal to the frequency of oscillator. Alright. Yes. This is the working principle of cyclotron. Now, let me write here the construction and working. Construction and working. It consists with two metallic Ds. You can see this is the metallic Ds. What is this metallic Ds, sir? So have you seen ever the empty box of Vicks VapoRub or the balm, like the Jandu balm? It is. If you will cut that box in two pieces equally, you will get this particular shape. This one. Alright, this is called the Ds. This is the metallic Ds. This is D1 and this is D2. This space is empty. Alright, this space is empty. It is placed in a magnetic field. This is the magnetic field from up to down. I am making this 3D. This is the horizontal. It is being placed horizontally and the magnetic field is coming. It is placed horizontally and magnetic field is coming from top to bottom. Here, these Ds are connected. These two Ds are metallic Ds are in examination. You must mention metallic Ds are connected here with source of AC. And this source of AC actually is called oscillator. Okay, this is the oscillator. Why we use to say this as oscillator? Because this oscillates the polarity. If it is positive and it is negative, then in every second this polarity changes 50 times. Okay, it reverses. We know that the AC moves plus minus plus minus. All right, that's why it is also called oscillator. This oscillator will provide electric field. We know that in metal the electric field will be established. So it will provide electric field if it is polarity if it is positively charged and it is negatively charged, then electric field will be in this direction. Remember, but this direction of electric field is not going to be sustained continuous. Okay, because when this will be positive and this will be negative, the electric field in this direction, but you know that 50 times this direction will change. After few seconds, fraction of second, the electric field will be in this direction, because this will be positive and this will be negative, because the polarity is going to be changed 50 times, positive, negative. All right. So as you will leave a charge, remember this is the D's, D1 and D2. Remember, this particular apparatus is being placed in cross field. All right, this is very important. It works between cross field. Remember, it works between cross field. What does it mean by the cross field? That is E perpendicular to B. Yes, must remember. Electric field perpendicular to the magnetic field. You can see if the electric field is maintained in this direction and magnetic field it is from here to here, it means electric field and magnetic field are perpendicular to each other. All right. Yes. This is the electric field and this is the magnetic field. It means both are the perpendicular to each other. Remember, the electric field maintained by this oscillator only in this free space. We know that inside the metallic disc there will be no electric field. Why? Electric field shielded inside metal. All right. but magnetic field is not sealed. So there will be magnetic field inside the D's, but there will be no electric field inside the D's. Okay, now we are going to start its working. This is the construction, my dear students. All right, if you will leave a charged particle, okay, here we are having a window, a very small hole, the window. As we will place a charged particle, suppose at this point the electric field will carry this charged particle towards the field as it will move, but inside the D's there will be no electric field and only this charged particle move on circular track. Why? Due to the magnetic field. As this charged particle is leaving the field, here the electric field direction in this direction. Alright, but as soon as the charged particle is leaving this D's, the electric direction of electric field is going to be changed, and then this charged particle comes out. Remember, if the direction of electric field will not change, then again charged particle move in. Okay, it will not leave the D's. But here what I'm telling you, as soon as the charged particle about to leave the D's, the direction of electric field changes from the oscillator. Remember, this charged particle continues circulate and its radius increases. Why this radius increases, I will explain you. And after some time it leaves the D's by this window and hit the target. This is the target. After increasing its radius, its energy increases after each rotation, and energy increases enormously, and then it hits the target moving out from the window. This is the working of cyclotron. Alright, now try to understand how the radius increases, and the second thing, what is the meaning of this principle. Try to understand, my dear students. Remember, listen carefully. As this charged particle is leaving the D2, all right, is leaving the D2, the polarity should be changed. It means the charged particle having the time, or the oscillator have the time to change its polarity. Meanwhile, this charged particle leave the D's. It means the frequency of changing the polarity should be equal to the frequency of motion of charged particle. If the frequency will not equal, this D's have the time to change the polarity in time being this charged particle leaving the D's. It means the frequency should be exactly matched. If the time or the frequency will not match, then what will happen? Suppose if the charged particle is leaving and the polarity does not change, then the charged particle will stop and it will move back to the D's too. So the kinetic energy will not increase. It means this principle should not fail. Alright, so this is the working of cyclotron. Now we will try to understand how the kinetic energy increases. Remember, we know that the formula of radius already we have discussed in our previous classes. Okay, in few previous classes. It is the kinetic energy we can write here. If the charged particle is moving with the potential, then Q and V is the potential, is equals to the half m, suppose u square. It is u is the speed, and already we have calculated the radius. Okay, before this much we have calculated the radius. It was the root under 2 pi m by q v square. You have to write actually that equation, okay, of the radius. You will write that equation. Now, as the radius will increase, remember the kinetic energy will also increase. Yes, am I right, my dear student? Yes, as the radius will increase, the kinetic energy will also increase. Now, Look at here. The charged particle projected at certain angle inside the D's. Look at here carefully. And we know that the angle which is made by the magnetic field, the charged particle leaves the field at the same angle we have discussed. So due to making some angle, its radius little bit increase. It goes inside the second D's at the increased angle, and again it try to leave at the increased angle. So after each circular motion, its radius increases by a small amount. Are you getting me, my dear student? And here we can write the kinetic energy half m and v. What is v? It is nothing but qbr by m square. Alright, so you can see by increasing the radius, the kinetic energy is going to be increased. By increasing radius, kinetic energy going to be increased. So you can see after each rotation, the kinetic energy increases. And this is the working of cyclotron. Student, you can see here the frequency, and we have already studied the equation of frequency. It is the qb by 2 pi m. You can also mention over there. Now student, its limitation. Okay, what is the limitation of cyclotron? So remember, it should not fail its principle, and the limitation. Kindly note down the limitation. The first will be, you can write, maintaining uniform magnetic field over large surface area of D's is difficult. This is the limitation of cyclotron. Alright, the second one, if circulating charged particle acquire very high speed, as we know that after each rotation its speed increasing because the kinetic energy is increasing. But if circulating charged particle, you can write, my dear students, all the limitation what I am telling you. If the circulating charged particle acquire very high speed, then mass will vary due to, according to the mass energy relation, that is the relativistic formula which was given by Einstein. So the second point, limitation, is mass will vary. What was the first? It is very difficult to maintain the very high magnetic field over the uniform, that is the uniform magnetic field over the large space of the D's. Then the second one, if the circulating charge particle acquire very high speed, then mass will vary. And if mass is varying, then we know that in frequency, my dear student, in frequency it was the formula qb by 2 pi m. Alright. If mass will vary, if this mass will vary, then frequency will change, and if frequency will change, then work principle become fail. Okay, so this is the limitation of cyclotron. Cyclotron cannot work beyond that, and we know that if any charged particle acquire very high speed and comparable to the speed of light, then mass will vary, and this is the limitation of cyclotron. Okay, student. So this is all about the today's lecture, my dear students. Thank you very much.